Guys, I hope you're all doing well. Welcome to our fourth video and chapter, which is starting a new project. So generally speaking, when you are inside Revit, there is a methodology that you are able to follow when it comes to starting a new project. I'll just start a new project here, symmetric. So the idea is to kind of just have a setup of um, what it is you have in terms of information, particularly with a site. As architectural designers, we tend to design according to um, context, relatively with sites context, as well as also setting up levels, grids, and a site topography, which is something that you will then kind of start to design your building. So yes, generally speaking, when it comes to this, the space that you will be exploring essentially is here, massing in site. So I'll just open a new project with the template um, included. You can see here I'm opening a 2026 version and it's upgrading from 2024. And then you can just say some families, so you can delete that. So yes, here's our file that's open now. I'll just close these. So you can see here, we'll go into the ground floor plan area. So generally speaking, when starting a new project, the main thing to keep in mind is that there is a project base point versus a project survey point. So I'll just highlight this. This has been hidden, so I'll just select this, and you can see that's these points here. So if I highlight these and then I go to filter, you can see here, this is what we're talking about in today's lesson, just to get a better understanding of what it is that we are kind of looking at and speaking to when we mention a project base point and a survey point and a site. Before you model a single wall, every project needs to be positioned correctly, and Revit uses two reference points for this that often confuse people at first. So these are the 2 points that it uses. The simplest way to remember this is that the project base point positions the building on paper. That means that it's your internal reference for measuring distances within the project. And the survey point positions the building on Earth. It ties your model to real-world surveyed coordinates, such as latitude and longitude, or a civil engineer's site coordinate system. Um, the principle behind this is that when there are multiple disciplines that are linking models together, for example, architecture, structure, and civil, these shared coordinates are what keeps everyone's model aligned in the same location. So that is the relevance with this. This tends to come into play specifically when you are doing work shared kind of modeling. I'll just select these and then I'll just unhide so that they can show. I think the template has them hidden indefinitely. Okay, yeah. But yeah, just keep in mind that these are the 2 points that we are referencing. So you can see here, what that means is that also following that, when you are working in a Revit project, usually you will get information from a surveyor or civil engineer. So as I was saying, the idea will be that a civil or site surveyor will give you information in the CAD format. That's the format that most civil engineers tend to work in. So when you are bringing that inside of Revit, you'll come here to insert, and it's good practice to just say load or insert CAD. So you'll come here and say sorry. So yes, when bringing it in, it's good practice to just select import CAD as opposed to CAD link. What CAD link does is it tends to kind of be linked to your actual personal PC. So it'll be linked to your local file. So if you don't have this file within this PC, then it won't open in a separate PC. So then you'll just select your DWG, and then just also to keep in mind here, you can just select preserve,
there's what to detect, and then you can also select on where you want this CAD file to land. So select the file and then say OK. Our processes, and this is now our CAD DWG being brought inside of our Revit file so that we can kind of work with this. And yeah, this is the nice thing about Revit. I believe it's very compatible with CAD information. So this has come in just rotated. So I'll just rotate this again. Sorry about that. Yes. So yeah, when also if you do have a problem with this, you just need to unpin the element because it's pinned, meaning that I'm not able to actually move it. Unpin it there. That's your point. Okay, that is our DWG brought in as an inserted link. Just a further distinction with the link. So the main idea behind why sometimes it's preferable to use a link would be that sometimes the civil or surveyor engineer will update the location of the DWG, and therefore this link will automatically pick up that that file has been updated in terms of its location. So when you do load it in, it will automatically change locations as opposed to you manually just kind of moving it, which tends to also cause other issues when it comes to location. Awesome. So you can see here, these layers are actually preserved. You are able to select this DWG file and actually explode this, which I don't recommend. It tends to kind of slow down Revit and it takes time to actually process. But you can see the various colors of these. This is all done in a CAD format file, wherein layers were kind of just used in that sense. The layers that are brought in aren't necessarily preserved in terms of line weights inside of the Revit Autodesk space, but we are still able to use this file to start to create a general mass for us to kind of work with. So that, just keep that in mind. Once you've got the site plan linked as an underlay, you are able to trace over it to build a topo surface, which is Revit's representation of the ground terrain, which is useful for site sections and grading. So from this space now, we can see this is our site. So we'll begin building our topo surface, which is a kind of mass format of information. We can see here, let's just play around a bit with our project base points. Zoom in, so it's just slow to process. Select, sorry, see what happens. Select that, filter that. Okay, if I move that, see that is our survey point. Just to keep that in mind, and let's see what happens if I you can see here these are the various level points that it has. Survey point internal, and then here if I select this, let's move this, okay. This is our project placement. You can see here, those numbers begin to change based on where we place it. So this point is generally where we had decided to place it, but we can place it there. Here. Let's see what happens if I rotate this. Yeah, so this is our site ST boundary corners. Another thing to keep in mind is also the levels. So I'll just select this section here. So if I double click this section, this here, I'll just go into a 3D mode just so you can see this. So you can see here, this is how this DWG has come in. We are able to just kind of like work with this information. If I do go into the section here, you can see where our actual level is versus the height of the DWG CAD. This isn't particularly a train smash when it comes to working with inside Revit, as it is just a reference point, so don't worry too much about this information just kind of being too high or too low to the point. You can even just bring it down if you would prefer, but essentially it would still reflect the same in a plan view, so to speak. So you can see here, another thing, like I said, that's good to keep in mind is the levels. So these are the levels that you kind of predetermine and use to start to build up your site, so to speak. You are able to kind of change the name if you double click this. You can also add a level. If you click a level here and just say CS, and you just draw one here, you can see where that level is created, and you can just rename this, say -02, and say lower basement, for example. And you can also change the height of this. You can change it by selecting it and moving up and down with the arrow, or just changing the value here. And yeah, just to keep in mind, levels are horizontal reference planes that represent things such as your ground level, first floor level, roof, and so on. They are fundamental because every plan in Revit is tied to a level. When you create a floor plan view, you're really just telling Revit, show me a horizontal slice at this level. So it's good to just kind of predetermine your levels early, because a lot of your modeling, such as walls, floors, will reference them for height. That's another thing. When you are modeling, it's good practice to just kind of link a wall. So I'll just draw this wall here. If I just go into sections of cutting it, but I'll just draw it through the section. So if I'll go into your 3D view, sorry. It's good practice if you highlight this wall, you can see here under its properties, you can kind of predetermine where you want it to end and start. So I could say perhaps that my top constraint should be the first floor and that my bottom constraint should be the basement, and that'll automatically update as opposed to just filling in values. So when you do say have a major change, you can just simply just select all the walls and then just update that accordingly. So yeah, that's good practice for you as well. So all of this is just a pre-setup just before you start to actually get to modeling. So just keep that in mind, levels, your AutoCAD DWG when you insert it, as well as another thing, which is before going to grids, I'll just explain a bit more about the levels. So you can see here, you are able to adjust the way in which this level looks. If you select that little elbow here, you can see that does that, and then you can also drag and drop here. Select that. You can also lock this or unlock it, and you can see it when you select it. It will give you like dimensions of how high it is in terms of like spacing, and you can also just click DI for dimensions just to confirm that it is the correct dimensions. You can see when I drag this, you can see the dimensions actually start to change. One more thing to keep in mind is the grids. So grids usually are only visible in floor plan. They are also in recent updates reflected in 3D, which is very cool. So I'll just draw these grids here, just as an example. Cross, cross, cross. With grids, you're able to also just adjust the way they act. So if you drag this to align it, you can just kind of move your mouse across, and then you can see that snap, just so it actually snaps to the other grids, and you can rename them. So if you rename them accordingly, you can say 01. Yeah, and then you can start to change the other ones, but usually it does do it in increments if you don't have a template set up. If I go into 3D here, I'll just select this and then I'll just hide in place. So yeah, these grids here are useful also for setting up in terms of just getting a better understanding of your site. So if you are perhaps doing a multi-floor plan, you can also just kind of drag this and then just draw. And then to space it out accordingly, instead of just kind of manually doing it, you are able to just click DI and then dimension each grid and do that, and then again do that, and then just, you can see here when you are about to finish, you can select that EQ. So that'll equalize all the grid spacings. Select here and you can say EQ. So grids are the reference lines, which are usually labeled with numbers and letters that architects and structural engineers use to align columns, walls, and other elements consistently across every floor of a building. So these usually come into play when you are dealing with more than one floor. Once placed, they show up in every plan view, and they're huge help. They are a huge help for keeping a multi-story building coordinated. So it is generally good practice, especially when you are working with structural engineers, to kind of align with where columns will be placed. So you can see here, for example, now I'll just place a column and I'll just make sure it's structural. There's no columns loaded, so I'll just go log one. From here, English, UK, columns. I'll just select one here and just select this one, rectangular. Say okay. You can see here, it automatically snaps. You can see those few lines that are highlighted, and it's snapping to the center of it. So if I select there, I can even say something like similar, and then you can also predetermine how high this grid must be, this column must be in the space here. And then you can start selecting and aligning it to the grid. Just to finalize, we can quickly just create a site, mass topper surface. So I'll just reset this here quickly, and I'll just come here, just as good practice. After this, you guys will do your own. We can say create from import. So there's nothing actually, just actually create from CAD. So that's another thing to keep in mind. You are able to create from Sketch or create from import. Let's just see what it creates when I say create from import, create from CAD. Select this. You can see here it gives me all these points. So I'll just say check none, and then I'll just find our site. Let's see if we have one. If not, then we can just create it manually. Okay, there's nothing here currently, so we will just create it manually. Say click cancel, go back, topper solid, create from sketch, and then you can start to place your points. So you just do this. Just here. You can also just select this tool here, which is pick lines. So you can just do that there, that line, that line, that line. Then you can trim and extend, TR, do that there. Just make sure they align. Do that there. Just one more here, so it's a bit more accurate. Trim and extend these two here. There, and I say okay. See here, that is our site created. So another thing also that's good practice, you are able to use that as a reference to create your site. You can either use this topper solid or you can use the floor, which is here, and you adjust it. But generally speaking, good practice also use this site topper surface, and then you select this. You can see here you're able to adjust it accordingly. So you can say change the thickness. So if I change the thickness there, you can see here it's now thicker. And then you can say modify sub elements. What that means is now you can actually add points within this to kind of adjust the way in which this looks. And then you can kind of start to create various types of points, which will start to give the model a sense and feel of an actual topper surface. You can see here, when I start to drag and play around with these points, the topper surface actually changes. see here, I'll just drag this here. You just reduce this here, smaller. Just escape. I'll just hide this in place. So I'll just select this and then hide an element. And you can see here, this is now what our copper surface starts to look like. So this is all built from kind of creating a grid and also like predetermining levels. Thereafter, we can just generate this. So this will obviously not be as accurate, but it will, because it's not created from an actual CAD file, but there is a possibility to do that if all your information is in place and the CAD file has that information. Okay, cool. Thank you guys for attending. I'll just have you guys just do small exercise when you are just generating and creating levels, grids, and then importing this CAD file, just so that you can kind of also create your own top of surface and yeah, explore that. Thank you so much. I'll see you in the next one.